This is Algebra 1, Lesson 7-2. We are solving systems of linear equations by substituting, beginning on 405. Okay, here are your steps for solving using substitution. First thing you want to do is you want to solve one of the equations for one of its variables. So what we want to do is we want to isolate, another way to say that is to isolate one variable. Just like we did on the bell work, how it says solve for y. You don't have to solve for y every time. Isolate the easier one, whatever one's easier out of x and y. Step number 2 is to substitute the expression from step 1 into the other equation and solve for the other variable. So if you have step 1 says x plus 1 equals 2y, for example. If you wanted to isolate x and get x all by itself, you would subtract that 1 on each side and get x equals 2y minus 1. Now you have an expression and x is isolated all by itself. So step 2 is to substitute that 2y minus 1 part in place of x in the other equation. And we'll look at an example like that in a second. Step number 3 is to substitute the value from step 2 into the revised equation from step 1. So if the other equation said 2x plus 3y equals 8, then in place of x, this one, you would plug in or substitute in 2y minus 1. Then once you got the value for y, you'd bring it back and sub it back into the other equation. It'll make more sense when you see an example. And then just like graph and check the solution in each of the original equations to make sure that you have a true statement. Here's example number 1 to make a little bit better sense seeing what's going on. Okay, it says tell which equation you would use to isolate a variable and explain your reasoning. So if we just look at the first equation for A. So if you just look at the first equation from A, it says 6x plus y equals negative 5. The one you would want to isolate out of 6x and y would be y. Because 6x, if you moved y over, you would still have to divide by 6 to get x by itself. If you just move 6x over, though, all you have to do is subtract 6x to get y by itself. So you're going with the easier one. If you pick the wrong one, it's not going to make the problem wrong. It'll just be an extra step or so that you wouldn't have to do if you use the other one. Same thing with the second equation from A. It says 2x minus 3y equals 10. Both of those multiply by something. X multiplies by 2 and y multiplies by negative 3. So either one would make you one more thing you have to do. So what you're looking for, just to sum it up real quick, is you're looking for a coefficient of 1. That makes fewer steps for you to do. For B, you have 5c minus 2d equals 1, and c plus 3d equals 0. So the easiest one here would be that one, because its c's coefficient is 1. It's less steps or fewer steps to do. So just to explain a little bit better what I just said, it would be easier to isolate y in equation 1 because the coefficient is 1. And it would be easier to isolate c in equation 2 for B because the coefficient is 1. Again, that's what you're looking for, the coefficient of 1 right there. That's the one you want to isolate if it's available. Example number 2 is the substitution method. Again, if you look at the two equations, one of them is 2x minus 5y equals negative 13. The other one is x plus 3y equals 1. This is the only one that has a coefficient of 1. That's the one you want to isolate. The easiest way to do the substitution method is not stacking them on top of each other like you'll always find them. The easiest way to do the substitution method is to write them side by side. 2x minus 5y equals negative 13, and x plus 3y equals -1. Again, you want to try to isolate that x that has the 1 coefficient. So all you're doing is getting that x by itself. In order to do that, bring the 3y over by subtracting 3y on both sides. And you have x equals -1 minus 3y. So what you have at that point is a value for x, and x is all isolated. You take that expression, -1 minus 3y, and you bring it back into the other equation, and in place of x, you plug it in or you substitute it in. So 2 times x, substitute -3y. Notice they just wrote it backwards from what I have. I have -1 minus 3y. Same thing. Substitute that in place of x. So instead of 2 times x right here, now you're going to have that value -3y minus 1. Notice it just took the place of x. It's substituted in for x. And in doing that, you go from having 2 variables, both x and y, to now you only have 1 variable, y. There are 2 copies of it, but there's only 1, which means we can substitute or we can solve for y. So when you distribute 2 to both of those terms, 2 times -3y is -6y, 2 times -1 is -2. So -6y minus 2 minus 5y equals -13. Then combine your like terms. -6y and minus 5y is going to give you -11y. -11y. So now you have -11y minus 2 equals -13. So now just solve for y. Add 2 to both sides. When you add 2 here and here, you get -11 on the right to go with -11y on the left. Then to get y by itself, divide by -11. A negative divided by a negative is going to be a positive. So y's value is 1. So when we did all of that work, going back up to what I had written earlier, all of that work that just happened gets us to y equals 1. Once you have that value, y equals 1, you bring that back and plug it in place of, oh, we don't even have to go to that one. We can plug it into the one we worked to get x by itself. X equals -1 minus 3, but instead of times y, it's the new value of y, which is 1, and that's what we're going to do here. So find the value of x by subbing 1 for y in the revised equation and solve for x. So now x is, instead of -3 times y minus 1, now it's -3. Notice 1 is what we subbed in for y. So now -3 times 1 is -3 when you multiply them. And then when you take -3 and subtract 1 from it, you get -4. So now you have x's value, which was, you just got x's value, -4. You had y's value, which is 1. So written as an ordered pair, x comma y, your solution is going to be -4 comma 1. So now you have the solution. Now plug both of those back in and check it. You always want to check it. Remember, you can do a lot of your checking mentally, especially if the numbers are easy for you to remember. For equation number 1, 2 times x, we just got a new value for it. It was -4, so it becomes 2 times -4. Minus 5, we got a new value for y. It's 1. So 2 times -4 is -8. -5 times 1 is -5. -8 minus 5 is -13. Notice that's a true statement right there. -13 is equal to -13. Same thing with equation number 2, the original one. X plus 3y. X is -4. So -4 plus 3 times y, 3 times 1. -4 plus, it's going to be 3, is going to be equal to -1. -4 plus 3 is, in fact, -1. So that is a true statement, just like -13 was equal to -13. So the solution is the ordered pair we got a little bit ago, -4, 1. Okay, solve this linear system. Do it on the back. Take about a minute and a half or so. Remember, the easiest way to do substitution is 2x plus 6y equals 15, and then write the other one next to it instead of stacked on top of it like that one. Try it that way. Okay, the easiest one to isolate is already isolated for you, that 1x over there with the coefficient of 1. It's already all by itself on one side of the equal sign. So x's value is 2y. What you want to do is in the other equation, substitute it in. That's why this is called the substitution method. So what you have is 2 times our new value for x plus 6y equals 15. And our new value for x is 2y. That's the substitution part. So just simplify that. 2 times 2y is 4y plus 6y is equal to 15. When you add 4 and 6y together, you get 10y equals 15. And in order to get y isolated, or to get it by itself, you would divide by 10. The number 5 goes into both 15 and 10, into 5 3 times, into 10 2 times. Now we have a value for y, 3 over 2. We don't have a value for x yet. We know it's 2 times y. So in order to find out what it is, take that new value, 3 over 2, and plug it in to the value for y. So x is equal to 2 times our new value for y, which is 3 over 2. When you multiply straight across, 2 times 3 is 6. 1 times 2 is 2. So x is 6 divided by 2, which x is 3. Now you have an x and a y value. X comma y would be 3 comma 3 over 2 as your ordered pair. So this would be your solution. Check that solution in the two equations. 3 times, this is an easy one right here to check. 3 is going to be your x value equals 2 times 3 over 2. So 2 times 3 is 6 divided by 2. That's 3. That one checks out. The other one, 2x plus 6y equals 15. When we try that one, 2 times x is 2 times 3, which is 6, plus 6 times 3 over 2. 6 times 3, you know, is 18, divided by 2 is 9. So 6 plus 9, it says, equals 15. That's a true statement, too. So this is the solution to your system. This is the point that when you graph both of the lines, that's where they intersect. At 3, 1.5. 3 halves is 1.5, if you're thinking about how the numbers are going to look on a graph. Try this one. 3x plus y. Again, it's easier to write them side by side instead of stacked on top of each other. Next week, we're going to talk about with something called the elimination method. The elimination method is better to stack them on top of each other. But for right now, the substitution method, Write them side by side. Determine which one is the easiest one to isolate. One of them's not isolated like on the last one. Isolate it and then plug that value into the other one to solve what it is. Take about a minute and a half. All right, let's take a look at it. We're going to run out of time. The easiest variable to isolate, the easiest one to get by itself is this one right here because its coefficient is 1. So you want to get that y by itself. In order to do that, you want to bring 3x to the other side of the equal sign. So y equals 3x was positive on the left. When you undo that plus 3x by subtracting it, it becomes negative 3x on the right. Positive 5 is already on the right, so it's going to stay there. Notice what we did right there is we got y isolated all by itself. Take this value or this expression that represents y and substitute it in for y in the other equation. So 2x, it's still 2 times x, minus our new value for y, which is negative 3x plus 5, is equal to 10. So what you have here, don't lose the fact that this is a negative 1 right here. You have to distribute that negative 1 to all of the terms in the parentheses. A negative times a negative is going to be a positive 3x. A negative times a positive is going to be a negative 5. Bring the rest of it down. 2x is still there, equals 10 is still there. Combine your like terms, 2x and 3x, to get 5x. Minus 5 equals 10. Undo minus 5 by adding it to both sides, and you'll have 5x equals 15. And then undo 5 times something by dividing it on both sides to get x's value is 3. Now we have a value for x. We still don't have y, though. In order to get y, take this value for x and sub it back in to that equation right there. What that gives you is y equals negative 3, now times our new value for x, plus 5. We found out our new value for x was 3. Negative 3 times 3 is negative 9 plus 5. So negative 9 plus 5 is negative 4. X's value was 3. It's x comma y. 3, negative 4 is your solution. Plug it back in mentally to make sure that it works. 3 goes in place of x. 2 times 3 is 6. Minus a negative 4 means plus 4. 6 plus 4 is equal to 10. It works for that one. 3 times x is 3 times 3 is 9. Plus negative 4. 9 minus 4 is equal to 5. That one works as well.